Electrical engineering is a branch of engineering that studies, designs, and applies equipment, devices, and systems that utilize electricity, electronics, and electromagnetic. It arose as a distinct employment in the later part of the 19th century, following the commercialization of the electric telegraph, the telephone, and the generation, distribution, and use of electrical power. Primitive batteries and static charges were used in early electrical experiments. The real design, development, and production of usable devices and systems, on the other hand, began with the application of Michael Faraday's law of induction, which says that the voltage in a circuit is proportionate to the rate of change in the magnetic field through the circuit. This rule governs the fundamental principles of the electric generator, electric motor, and transformer. The introduction of electricity to households, companies, and industry marks the beginning of the modern era, which was made possible by electrical engineers. Common electrical engineering subdisciplines include the following. Number 1. Control engineering. This field focuses on controllers, which are used to make systems behave in a specific way. Aerospace flight and propulsion systems, as well as industrial automation and robotics, are examples of these systems. Control systems are frequently built to offer performance feedback that may be used to monitor possible issues or influence automatic reactions from autonomous drones, cars, and other systems. Number 2. Computer engineering. Computer engineers create computers and computer systems for physical devices such as desktop and laptop computers, video game consoles, mobile phones, robotics, and other electronic devices. While software engineering is commonly thought of as a separate subject, computer engineers may also work on the software of a system. 3. Electronics engineering. This type of engineering, formerly known as radio engineering, includes the design and testing of electronic circuits for radios, communications and radar systems, and early television. Modern television and audio systems, computers, and microprocessors were added to the field. Number 4. Power and energy engineering. This engineering discipline is concerned with the generation and distribution of energy, as well as the design of associated equipment such as electric generators, motors, transformers, and other power systems such as electrical grids. These engineers work on conventional, nuclear, and renewable energy solutions. The 5th one is telecommunications engineering. This technical discipline focuses on communication transmission via cables, optical fibers, and the atmosphere. Transmissions over the atmosphere necessitate the encoding of information in a carrier signal in order to shift the information to a carrier frequency suited for transmission. This process is known as modulation. Amplitude modulation and frequency modulation are two popular analog modulation methods. The choice of modulation impacts both the cost and performance of a system, and the engineer must carefully balance these two variables. Electrical engineers operate in a variety of settings, depending on their function or specialization. A large portion of this job will be done in an office setting, including design work for new systems and technologies. However, working on site to monitor and test electrical systems for buildings, transportation systems, and power distribution networks may be required. These engineers may be found in a variety of industries, including construction and building services, energy, manufacturing, telecommunications, and transportation. Most electrical engineers enter the field through a university degree program. However, it is possible to become an electrical engineer through a college course, an apprenticeship, or working toward a job in a similar subject. The university approach would entail a degree in electrical or electronics engineering, electrical engineering technology, or electrical and electronics engineering. However, all of these engineering programs should teach the same fundamental ideas. The bachelor's degree will often cover disciplines such as computer science, physics, mathematics, and project management, in addition to electrical engineering topics.